Good morning, this is your Stat Sensei, Mr. Spensei, and this is a warm-up on reading a computer printout. So, sweet. Is there a relationship between the amount of sugar in candy and the number of calories? So right there we know we're looking at our X and Y, and our table indicates the sugar is our X and calories is our Y. Further, when we come back to this, we know that this is going to be my X variable. So a random sample of 12 candies. And remember, degrees of freedom is n minus 2. So 12 minus 2, which is where we get these 10 is our degrees of freedom. Okay, so this is the degrees of freedom. Um, was recorded in the table below and resulted in the following computer printout. So I just want to let you know that all this data right here, I went ahead and entered it into stat edit. So if I go to stat edit, and I have 45, 450, and all the data there. And then I went ahead and ran a test, stat test, linear regression t-test, alpha trace, and we see that we have a t-statistic, a p-value, our y-intercept, and our slope, and our standard deviation of residuals. And you can see that here we have a y-intercept, our slope, standard deviation of the residuals. If I scroll further down, we have our correlation coefficient, etc. So taking a look at this and answering the questions, it says, hey, where's our explanatory variable? Well, the first thing we need to do is identify our y-intercept row. This right here is our y-intercept row. We know that because of the word constant. Constant's what clues us off. And the row directly below it, wherever it occurs, is always our slope row. So this is our slope row in pink. And the explanatory variable we already marked as X. And so our explanatory variable in this case is sugar. And it happens to be measured in grams. And so this is letter A. All right, the y-intercept. Well, obviously the y-intercept is going to be on the y-intercept row. Second, on the y-intercept row. And it's the very first number on the y-intercept row, which is 300.0397. Then our slope is going to be directly below it. And of course, the slope is going to be on the slope row, and it's going to be 2.829. Now, we could have standard error of the slope or standard deviation of the slope, but we know it has to be on the slope row. So we know it has to be in the pink. And right now we have standard error, but sometimes it'll say standard deviation. So our standard error of the slope is 1.1374. Then it asks for the regression equation. And I can write that two ways. I'm going to write it one way using the y hat. Y hat equals 300.0397 plus 2.829x. And then my preferred way of writing this is our y hat. Well, we just said earlier that our y was calories, our x is sugar. So for y, we're going to plug in calories. And we'll put a hat on it equals 300.0397 plus 2.829. And our x, we said, and we said it here as well, is sugar. And just as a reminder, I'm going to go ahead and put a y here and an x there. Okay, this is my preferred way. This in blue is my preferred way, but this is not wrong either. Key statistic for the slope. Well, on the next one, we notice we see the word slope, so we know they're going to be on the slope row, so they're going to be in pink. So we find our t statistic that matches up with our slope, and that's going to be 2.4871. So that's our letter F. And then it asks for the p-value. Well, our p-value is also going to be lined up on the slope row because it's the p-value for slope. So we know we're going to be pink. And in this case, it's 0.0321. All right, coefficient of determination. I can look all over here and I don't see the coefficient of determination, but I should remember by now that coefficient of determination is my r squared. So I need to go find my r squared, and it looks like I have two of them. I have a 38.22% and a 32.04. We will never use the r squared adjusted, so our answer is 38.22%. Make sure you put a percent sign. And remember, when we ran this on the calculator, I got an r squared of 0.382 because all they did was turn it into a decimal, which means they divided by 100. All right, the correlation coefficient. Well, the correlation is sine of the slope. And if I look at my slope is positive, so I need a positive correlation coefficient. And I need to take the square root of r squared. So if I'm taking the square root of r squared, that means I'm taking the square root of 0.3822. And once again, that's the same as the coefficient of determination, or r squared. So 0.3822 and raise it to the half power. And I have 0.6182. So taking the square root of that, 0.6182. And the very last thing it asks for is the standard deviation of the residuals. And the standard deviation of the residuals I like to think of as the big S, because most of the time it's just an S off by itself, and it is here as well. And that is 105.46. And this set measures the amount of variation in calories for a specific amount of sugar. All right, specific number of grams of sugar. So that's standard deviation of the residuals. All right. And the difference between standard deviation of the residuals, the standard error of the slope measures how much the slope can vary. So it could be, oh, it could vary by this much. Here we're saying, hey, the the um, standard deviation of the residuals, how much variation we can expect in the amount of sugar based on a specific amount of calories. All righty. Appreciate you watching and look forward to seeing you on the next one. Thank you.